Good morning everyone. Welcome back to my channel. Today I am going to teach you about relation and functions chapter. In the 3 marks question I will be discussing. That is, this question is asked in 2014 question paper. 3 marks question. The question is, show that the relation R in the set Z of an integer given by R is equals to A comma B such that 2 divides A minus B is an equivalence relation. Already I discussed what is meant by equivalence relation in another video. What is meant by equivalence relation? If it satisfies reflexive, symmetric and transitive. Here, reflexive, symmetric and transitive. If it satisfies this, then it is said to be an equivalence relation. So we have to prove that reflexive, symmetric and transitive. The solution is given R is equals to A comma B such that 2 divides A minus B given. So A comma B belongs to R, 2 divides A minus B. So first one, reflexive. To prove that, TPT means to prove that R is reflexive. R is reflexive if 2 divides 0, that is 2 divides A minus A. A minus A is 0. So 2 divides A minus A. Therefore, by definition of reflexive, A comma A belongs to R. Therefore, R is reflexive. To prove that R is symmetric. A comma B belongs to R. 2 divides A minus B. Also 2 divides minus of A minus B. And 2 divides B minus A. That is minus A plus B. I am writing plus B minus A. So, if A comma B belongs to R, then B comma A belongs to R. By the definition, we know that symmetric means A comma B belongs to R and B comma A belongs to R. Therefore, R is symmetric. Next, to prove that R is transitive. By definition, we know that A comma B belongs to R and B comma C belongs to R implies A comma C belongs to R. By definition, we know that. So, 2 divides A minus C. By definition, 2 divides A minus C. If 2 divides A minus C, then A comma C belongs to R. Therefore, R is transitive. By 1, 2 and 3, R is equivalence relation that we proved. R is reflexive, R is symmetric and R is transitive.